everyone. Thanks for joining me. Yep, that's the title of the talk, MVI with Jetpack Compose. First, I'd like to say something about me. I'm Luca Nicoletti. I'm an Android engineer. I'm currently based in London, where I work for Babylon Health. I have a few questions for the audience. Any of you have ever heard about MVI? Okay, does any one of you use it in production? None. Okay, perfect. Not yet. So same question for Jetpack Compose. Anyone has ever heard about it? I hope so now. Okay, perfect. Anyone have tried it? The alpha version. Okay. Anyone have downloaded the repo before the Dev Summit? One of them. Perfect. Okay, so, well, as you can see, both of them, MVI and Jetpack Compose, are quite new technology in the Android world. So let's start. MVI, it's an architectural pattern which allows us to consider an application as unidirectional data flows, which has no start or end and can be considered as a loop. For now, let's assume that it has a beginning, and this point is the user interacting with the UI of our application and producing intents. Those intents, through the business logic of our application, manipulates the model, updating it. The updates on the model are then reflected to the view component, and the view component is then rendered back to the user, completing the loop. MVI tries to follow some core principles. It's unidirectional, so data always flows in one direction without going back and forward between two components. If you have two components communicating both ways between them, there's something wrong. It's immutable. The state never changes. The business logic of the application should create new instances of the state every time, and it's reactive. So the user inputs, the action performed by the user, are considered part of the architecture. And it's also functional. MVI tries to consider everything as a function. So as this pattern treats everything as a function, we can also represent it this way. Those functions are also meant to be pure. That means that with the same output, performing the same function, we have always the same output. So we assume that the flow starts with the user interacting with the application and generating action or intents. But we know that it might not be the case. We could also want to perform some action based on a system event, like lifecycle events in Android. That's why we ended in our implementation of MVI, we ended up accepting something instead of user interaction. We start with an initial state, and then any action which comes in, even lifecycle events, create a new state based on the previous one and the action itself. We are so generic because we wanted our architecture to work as a headless system without any UI. So every single MVI implementation I've seen has different naming for almost the same components. In our architecture, we have actions, which are generated by the user or from the system. We have transformers, which are the components that apply the business logic of our application. We have reducers, which generate new states, and the states themselves. But how do we know which action we need to apply, to which action we need to apply which transformation? We have another component, which we call the middleware, which works as a glue. That means that it binds action to transformers and transformation to reducers. This component can also bind action to reducer directly. That's because business logic, it's not always what we want to do. A basic example will be a checkbox. We don't need any additional business logic on that. We just want to reduce and generate a new state in order to render it to the user on the action of the user clicking the checkbox. Another example will be a rating. This is some code we have in our application in the MVI architecture. The perform action just state what's going on there. We then have an action coming in, which is the rating selected performed by the user, and we apply a reduction, which is reduce rating selected. That function generates a new state with a new value, which will be rendered to the user. As you can see here, there's no transformation. On top of that, we can also bind multiple actions to the same transformation and to the same reducer. In this case, we're loading the patient data, and as I said before, we're not relying only on user interaction, but also on lifecycle events. Like in this case, it's the activity or the fragment being created. That's why we don't want the user to do something on a screen before its data being loaded. So how does this MVI architecture help us? Well, it helps us decoupling. Of course, every architectural partner helps with this. We have no classes which serve more than one purpose. And yeah, another thing that it helps us with is testing. We are able to test almost every component of our MVI architecture without relying on the Android framework. That means that those tests are run just with Java, just with a Java virtual machine, and don't need any devices or emulator. The only component we rely on the framework to test is the view. That's because the current state of the Android doesn't allow us to detach the view from the framework itself. Those tests are, I consider them to be end-to-end tests. They represent the entire journey the user would perform in our application. So for example, the appointment walkthrough test is a test that starts the application from the splash screen and walk through all the action that the user will perform. So open the application, tap on the appointment, book an appointment, and those tests run on emulators and also test the other components which we already are testing in isolation. As I said, we are bounded to the system with activity and fragments and layouts. And we end up having the render function inside the activity or the fragment, or with a renderer class, which then has a render function that reference XML layouts. As we can see here, the render function accepts a state, which represents the current state of the screen, and reference XML views. And in order to show or hide them, we rely on variables on the state. The show function, it's nothing special, just hide or show the view. We also use this approach to enable or disable menu button, so another time bounded to the system, and also with dialogues. Just one more thing before we start talking about Jetpack Compose. We are testing our implementation of MVI from several months now in production, and we're pleased to say that we're open sourcing it. Stay tuned, it's coming, really neat. We already went through a lot of problems which MVI comes with in the Android operating system, and we choose to help other developers solve this problem as well. So Jetpack Compose. So not all of what I will say has been documented or confirmed by Google at this point. And with the Android Dev Summit, which happens 2 days ago, something might not be up to date. So the first time we've heard about Jetpack Compose was back at Google I/O 2019. There was this session, Declarative UI Patterns with Android Jetpack. They slightly introduce some concept on Compose and show some demos, really basic examples. On the Dev Summit this year, there was 2 other sessions. What's new in Jetpack Compose and Understanding Compose by Leland. The first one was the state of the website as the day after the Google I/O. There was this note saying that Jetpack Compose was in a pre-alpha early exploration pre-alpha stage, and its API were most likely to change. Now they've changed it, and they're more clear about them. Changes are planned and expected, and it's in a developer preview. So what is Jetpack Compose? Jetpack Compose, it's a UI toolkit which allows us to use a declarative UI pattern. A declarative UI describes what you want instead of how to achieve it. A really basic example would be a column with 3 components. In a declarative way, you should just say 3 blocks. In a procedural way, instead, you need to say how to display those blocks. The old way to do that in Android was with a layout file. You had to create a linear layout, specify the orientation, which has to be vertical, and then you have to declare the 3 components you want. Flutter, which instead use a declarative way to design interfaces. You just say, I want a column with 3 children, which are the text, and this is the result. Pretty easy. Compose allows us to do the same. You just say, I want a column with 3 childs, which are text, and that's the result. So Jetpack Compose, it's based on component, and it's concise and idiomatic, thanks to the Kotlin language. It's based on components, and those components are meant to be stateless or stateful. And also, you should reuse them as much as you can. Jetpack Compose, it's also meant to be compatible, and by that they mean that they announced this generate view annotation, which would generate a view from a function, which you then could use in an XML file or also in the code. This is because they want to help us developer migrate slightly to Compose and not just start a new application and ditching all the code we already have. So this annotation was present the day after Google I/O, was then removed a few days after without any explanation. So if you were using it, you just found error in your code. And in the Dev Summit 2 days ago, they talk about it again. So I hope it will come back. Jetpack Compose, it's also meant to be unbundled from the OS. This means that the version of the UI, it's not bound to the version of the system anymore. And it should be easier for us to avoid compatibility issues between different API levels. So to try Compose after the Dev Summit, you can do it easily, sort of. You just need to enable Compose in the build features, set the Java version to 1.8, both for Java and Kotlin. You have to add some dependencies, of course. You have to use the Gradle version 4 or more, and the Kotlin Gradle plugin version 1.2. Then you need to add all the dependencies to the framework, to the composable core part, which are those views, and also add a runtime. On top of that, you can't use your current version of Android Studio. You have to download the preview release, the Unary build, which is now to the version 4. Otherwise, before the Dev Summit, you have to set up repo by following those nice code lines. Download the entire repository, and they also talk about it in the developer website, suggesting you to grab a coffee because you were going to download 6 gig of data. And on top of that, also, you couldn't use your version of the Android Studio because it was missing the runtime plugin. You have to use a bundle version of the Android Studio, which came with the repo, but just by running Studio View. So how can you use Jetpack Compose? Well, it also starts in the activity and or activity for now, not fragments. And there's a new function, set content, which is meant to be used in the same way you were using set content view, but it's not accepting a layout resource anymore. It's accepting a composable functions, as we can see here. So this function is an extension function on the activity class. It accepts a composable function. It retrieves the content inside the root view of the activity and execute the composable function inside the view of that activity, making it the root view of that activity. So the setContent function, it's almost the same as the launch function for coroutines. It's a starting point for composable function. You can't call composable function outside a composition, which is started with the setContent function. But what's our composable function? Composable function are just function with no return type, annotated with the composable keyword, composable annotation, sorry. The annotation and the Jetpack runtime transform the function into a component. Leland, in his talk, said that there's no code generation at all. It's all run at runtime by the Compose runtime. At the Dev Summit, they also introduced a preview annotation, which is pretty awesome. It allows you to see a preview of your composable function. It's in a small window inside Android Studio. There's some complication though with this preview annotation. It can't be used on function which has parameters, not even if those parameter has a default value. And something that I found out this morning trying it, if you click on the preview in the nav bar, you can see that you're pointing to a test file.xml. So in order to show you the preview of a composable function, they're generating a XML file, which is using normal view, I guess, or they're just drawing on an XML file. So composable function, as they're not using the old views of Android, that needs to do something else. And what they do, if you deep dive into the code, they're calling a draw function, which is another function annotated as composable, which provides you a canvas. And they just draw whatever they want on the canvas. That means that you just have one view in the hierarchy, and it might be a problem. You're not able to inspect the view anymore. You can't select a view and see what's their padding, their margins, other stuff like width, height. You can't do anything. You just have one view with no data. We asked if there was something like debug pane states enable, which is a Flutter flag that forces the application to draw on the canvas margin and padding as well, but they say that it's not there yet. Trying it yesterday actually, I found out that they're doing some work. This is the current state. So right now you can see there's some more views, but if you select them, they're generic. The view selected should be one of those arc here, but as you can see, the bounds are pretty big. So they're doing something, but they're not there yet. So the previous example I showed were stateless. So they had no state. In order to create state, there are few ways to do that. One of them is the Unary plus state function. And side note that Unary plus is going to be away. They're going to ditch it. They're going to remove it, as they are saying for now. So the state function returns a memoization, which positionally memoizes the result of a computation. And this computation, it's built by initializing a state. The state is an annotated model class, which should wrap a single value. The model annotation represents your application data model. The instance of a class annotated with model becomes observable And every set on each property of that class trigger the invocation of the composable function in which you're using the variables of that class. So that means that every time you change something inside the model annotated class, there's a recomposition on the screen. Here is a basic example of a model annotated class. Keep in mind though that the observation is done on the setter method of the variables of the class. That means that if you have val or constant in your data class, the composable function which is referencing those constant will never be redrawn. In this case, if a change is done, a composition is redrawn. For now, there are some problem with hierarchy. And hierarchy is not accepted in a model annotated class. If you try to do so, you get a compilation error. You can inherit from interfaces though. So in order to understand a little bit more how Jetpack Compose works, we're going through some basic components that they're providing. Those components are coming with the first Android implementation dependencies I showed you before. So the seek bar, it's really simple. It memoizes the paint, it calls the draw function, and it draws two rects, which are the full width and the progress, and a circle. Really simple. It actually, some code is missing here. It wraps everything in a gesture recognizer in order to allow you to change the state of the seek bar. Dialogues are way more complex. Another dialog accepts a bunch of composable functions, some of them nullable, a close request, and an enumeration for the layout of the buttons. It then calls the dialog function, providing the onClose request, and wrapping all those composable functions inside here as a children. So the dialog function accepts a close request and children's. And thanks to Kotlin and trailing function, we're able to use this children parameter as we've seen before. So like this. So dialog set up some memoization on the context and the dialog wrapper. It then calls onActive. OnActive is a lifecycle callback called after the first composition is applied. So when it first reached the screen. And we can see here that they're showing the dialog and they're setting up the onDispose callback, which is another callback on the lifecycle events, which schedules work to be done when the effect leaves the composition. It then on the commit lifecycle event, which is called every time the composition commits, set the content of the dialog with all the children. Ripples. During the presentation, they joked a lot about naming convention they had in the Android source code. That's funny. Ripple rect. It's not a rect in my opinion, but well. So it all begins setting up a radius, a state, which is the status of the button, and a transition definition. It then set up two callbacks on press and on release, which update the state of this composable function. It wraps everything into a gesture recognizer and into a transition, calling another composable function, which is ripple from state. The ripple from state accepts the state of the ripple, which is a transition state. And, well, the to-do is self-explanatory. There are still some problems. He set up the position of the ripple and a paint to draw the ripple on. It retrieves the radius from the state, which is a transition state, as we've seen before, which is a model annotated class. And that will allow the draw function to be recomposed every time that state updates. And that's what creates the animation of the ripple expanding. The get alpha function just gets some value. They made a lot of changes in the Compose from the Google I/O to the Google Dev Summit. One of the biggest one in terms of also the mental model behind Compose is that they ditched the padding composable function. There was this padding which you could wrap your children with that would create some padding around the children. They didn't ditch it entirely, so the code is still there. You can check it out and save it for later. And they're ditching it in favor of a modifier, which is a layout modifier. And a modifier, it's meant to be used on composable function. And those composable that has modifier can be considered decorated or wrapped by that modifier. They also suggest how to use it. So if you're going to create your own component, they suggest you to use the modifier as a parameter, naming it modifier, and assigning a default value of none. Another change they did was about column and rows. They ditched the main axis size, providing a default value for now. So there's really a lot of work going on here, really a lot. They're working hard on it, but changes, as I said earlier, are expected. So changes like those ones are pretty easy to refactor. You just replace on the entire project and get rid of main axis size, get rid of it, and you're done. But changing as the padding getting removed, it's way harder. You have to change a lot of code in order to keep working, to have your project keep working. So now let's see how Compose and MVI could work all together. One of the first thing I thought about when I saw the Google I/O introducing this new Jetpack Compose thing, it was like, yeah, okay, that's nice, declarative way of UI in Android, really appreciated, thanks. But how can I use it in a production application? We have several lines of code already working. Can I just get rid of some lines, introduce some other new lines, and still have it working? So in my opinion, we could approach this merging of an MVI pattern and Jetpack Compose in two ways: an objective-oriented approach and a functional approach. In the objective-oriented approach, as we have states, we could declare an interface, which is a base view state, which has a composable function to build itself, so to display to the user the state. In this way, for every actual implementation of our view state, we have to override that build UI function, providing composable function, which will display what's really needed to the user. So we could get rid of the kind of render function I showed earlier. So let's see it in action. We start from the onCreate function of the activity. We set up the business logic component of our application, being it a view model or presenter or whatever. And then inside the set content function, we could set up a theme and render the state that our business logic emits every time. The render function accepts an observable on our view state, which is pretty easy. It set up a state by observing the observable that emits from the business logic, providing an initial value, and then you just need to call this state.buildUI. This function, it's from the code override a render function, just because I didn't refactor all the basic components we had in our MVI just to try it out, but it could be removed from the base view interface we have and could be an extension function on the activity. So we don't need to declare it every time. As we have the base views, the base state, we could do that, and it's written one time, used wherever. The observe function returns an effect of, accept an initial state, an observable, and returns an effect of. The effect class is a class that holds a block of executable code, which is meant to be executed positionally in the context of a composition. Effects are equivalent to composable function, which are able to return a value. So we could set up a result with an initial state. In the active life cycle, we observe the observable, updating the wrapped value inside our result every time the observable emits something new. And inside the onDispose, we dispose the observable. Side note, this wouldn't work right now. In order to have it working, you need to manually call Dispose Composition at the activity level when you want Compose to properly clean up after itself. It should do that by default on its own, but it's not done yet. So the Dispose Composition function is again an extension function on the activity which has no parameters, so it's pretty easy to call. As the set content, it retrieves the view of the decoder view, and then call compose.dispose composition on that view. The dispose composition dispose any composition previously run with the container on the root, and calls every onDispose callbacks that have been registered with that composition lifecycle observer. So what it does, it's really simple. It calls the compose into, which is basically the same as set content with nothing, and then set a tag. This tag is used, as Leland said in his talk, to save how our view is in a stack of in a list actually, which is used by the runtime compose to update the view. Going back to the observe function, we then return the result value, which again is a view state, and that will drastically decrease the code in our activity, because as we've seen before, it was just like 3 or 4 lines, being this declared once and the plus observe as well. The other way would be a functional approach. The functional approach, again, let's start from the onCreate of the activity. In the set content, we could call a postList screen function. That's code from some example I played around with, which accept the process intents, which again accept the intents. The intents, it's a function on the activity which exposes all the intents which can be emitted by the activity, so lifecycle events, user interaction, and what else. And it also provides a publisher, which allows the postList screen to set up callbacks, basically. The process intent returns a view state, again, accepting intents. It's subscribed to the intents and return a model state. The model state function is once again an effect of. So it's basically a composable function which holds a view state. Again, we need to set up an initial value, a disposable, in the onActive, which is again called every time the composition reaches the screen. We subscribe to our intents. We apply some business logic, API calls, reducers, whatever, and we subscribe to it, updating the value of our result every time. We then clear everything in the onDispose, and yeah, here as well, same problem as before. If it's not called manually from the activity, it's not working right now, but it should work easy, hopefully. And then we again return the result. So going back to the activity code, I just got rid of the publisher. It should be some more clear. The postList screen, it's a composable function which accepts a state. which, as we've seen, it's just processed by our intents. This post-list-screen function goes through every possible implementation of these states and draws whatever is needed. Here, there's in progress, we just draw a circular progress indicator. If we provide the intent publisher, as I've seen before, we could have an error state as well, which allows the user to click on a retry button, which triggers another action. So if we get rid of some noise around the function, we end up with the post-list-screen function, which accepts as input another function, which again accepts as input another function. And if we go back to one of the first slides I showed you today, this one, so how an MVI could be represented by pure functions, and we go back to our post-list screen, changing some colors, it's the same. We end up having a pure functional approach in an MVI pattern, thanks to Jetpack Compose. So those are some references, quite a lot now. The list was way smaller when I first gave this talk. I highly recommend you to give it a read, especially on the MVI pattern. It's awesome, really. And for Jetpack Compose, there's also a lot of video. Well, video, not that many, actually. It's just the two sessions from the Dev Summits and the first session at Google I/O. There's some nice Medium blog post, which guides you through the setup of the Jetpack Compose. And there are two blog posts from Leland. There's two. Compose from first principle and content on declarative UI. Both of them are really interesting. They include a lot of video and a lot of explanation on how the Jetpack Compose runtimes is actually working under the hood. And well, that's it for me. Thank you very much for joining me today.